In this section, we will talk about perfect hashing and collision. So let's see. And perfect hashing maps each search key into a different integer that is suitable as an index to a hash table. If we have perfect hashing, the result can be big or one search time, okay, which is very favorable condition. Okay, up to now, the two examples we come up with are perfect hashing. As you can see that, okay, each of the fruits are mapped to separate location in the hash table. They don't have the same location. And also in the previous example about division by 11, okay, you can see that they are all placed in the different locations in the array. So these two examples are perfect hashing. However, as you can imagine, as long as there's a term perfect, there will be some case of not perfect. It comes to the case. For example, if given this array, okay, if we want to add one more which has the key of 26 and the value is g, so how to handle? It will map to the same location as 2, which is already occupied, right? So we need to find a way that to solve it, and the problem here is called collision. The keys that have the same home bucket and are called synonymous because they are similar, okay, in terms of the location. And 22 and 26 are synonymous with respect to the hash function that is in use. So the home bucket for 26G already occupied in this case. Then we call it collision. So we have the better understanding about the collision is that when two values hash to the same array location, it is called a collision. And collisions are normally treated as first come first served. That is, the first value that hash to the location it gets it first. Therefore, the 22 is already placed in the location for 2. Therefore, it occupies this location, and it is not replaced by the newcomer 26. So we have to find something to do with the second one and subsequent values that hash to this same location. So this is another example. Okay, to let you see that, okay, both John Smith and Sandra D are mapped to the same location 152. So how to handle it? So here we will introduce some methods to handle this kind of location collisions. What can we do when two different values attempt to occupy the same place in an array? The first, okay, what we call solution 1 is called linear popping. We search from there for an empty location and can stop searching when we find the value or an empty location. So the search must be and around. Okay, like we will elaborate the meaning, okay, in the following session, but here we just give you some idea. And the second solution is called using some sort of linked list. Use the array location as the header, okay, use as a header instead of storing it, and the value that has to give location just give you the header. And all these solutions will work provided that we use the same techniques to add things to the value as we use the same technique to search it. That is, when you do the acting use one technique and we use the same technique for searching, then we can get the expected result for locating particular item.